Have you ever pondered over the sun, that massive ball of fire lighting up our days and warming our planet? It's the colossal celestial body that we can't help but take for granted, as it rises and sets each day with clockwork precision. Yet the sun is far more than just a reliable timekeeper or a source of light and warmth. It's a cosmic mystery, a riddle wrapped in the enigma of the universe. Imagine, if you will, the vast expanse of our solar system. Amidst the inky darkness of space, the sun stands as a beacon, its radiance reaching the farthest corners of our little celestial neighborhood. It's the heart of our solar system, the very lifeblood that keeps everything in balance. Planets, including our own Earth, orbit around the sun, held in their paths by its immense gravitational pull. But the sun's influence extends beyond just its gravitational prowess. It's the primary source of energy for life on Earth, fueling everything from the smallest microorganisms to the tallest trees. It drives our weather patterns and climate, and even has a hand in the ebb and flow of our oceans. Yet, despite its omnipresence and influence, the sun holds many secrets. How does it continuously burn without running out of fuel? What processes occur within its fiery heart that allow it to emit such colossal amounts of energy? And perhaps most fascinating of all, how does it affect us, the inhabitants of Earth, in ways that we might not even realize? The sun's story is one of cosmic proportions, filled with fiery birth, dynamic life, and eventual, inevitable death. It's a tale that weaves together physics, chemistry, and biology, shedding light on the intricate tapestry of our universe. So, how did this flaming ball of gas come into existence? Let's delve into the birth of the sun. Imagine a time, 4.6 billion years ago, when our sun was merely a cloud of gas and dust. In the vast expanse of the cosmos, this cloud or nebula was spinning in the darkness, a mixture of hydrogen, helium, and traces of heavier elements. It was a time of calm, but not for long. The nebula was about to undergo a transformation that would light up our corner of the universe. Gravity, the great sculptor of the cosmos, started to pull the gas and dust in the nebula together. As these particles drew nearer to each other, the nebula began to collapse under its own gravity. The center, becoming denser and hotter, birthed a protostar. But this was just the beginning of a much grander process. The protostar continued to grow, its core temperature rising until it reached a critical point. It was at this juncture, some 15 million degrees Celsius, that hydrogen atoms began to collide with such force they fused together, forming helium. This process, known as nuclear fusion, was the spark that ignited the sun's life. Nuclear fusion is not a quiet event. It releases an immense amount of energy, causing the protostar to shine brightly. The light pressure from this energy counteracts the force of gravity, stopping the star from collapsing further. A delicate balance between gravity and light pressure was struck, and thus, the sun entered its main sequence stage, the prime time of a star's life. But this was no ordinary star. This was our sun, the source of light and warmth for a planet that would eventually harbor life. Its birth wasn't just an event in cosmic history, it was the beginning of our history. A fiery ball of gas was born, and it was destined to become the heart of our solar system. After its birth, the sun went through a tumultuous childhood, much like a young star finding its place in the universe. Picture a young sun only a few million years old, in a cosmic playground. It's in the process of growing, accumulating mass, and getting ready to kickstart its nuclear fusion. This process, the core of what makes a star, involves hydrogen atoms colliding and fusing together to create helium. This fusion releases a tremendous amount of energy, which we see as light and feel as heat. But getting the fusion process started wasn't a simple task. The sun needed to reach a critical mass and temperature. Imagine trying to start a car on a cold winter's day. The engine needs a certain amount of heat to get going. The sun's core had to heat up to a staggering 15 million degrees Celsius. Only then could the hydrogen atoms overcome their natural repulsion and collide with enough force to fuse together. Once this happened, the sun started to shine brightly. It was no longer a mere accumulation of gas and dust. It had become a full-fledged star, shining and burning with the heat of nuclear fusion. But even then, the sun was still in its early stages. It was like a teenager, still growing and finding its place in the universe. The sun spent about 50 million years in this stage, growing and shining, before it finally settled into a stable state. It was a tumultuous time, filled with changes and growth. But as with any childhood, it was also a time of intense learning and development. The sun was learning how to balance its internal pressures and gravitational forces, how to regulate its fusion process, and how to shine brightly without burning out too quickly. And after these 50 million years of learning and growing, the sun was ready to move on. Its nuclear fusion process was well established. It had reached a stable size and temperature. It was no longer a young star but a mature one, ready to enter the next stage of its life. With its nuclear fusion process well underway, the sun was ready to enter its adulthood. Now the sun is in its main sequence stage, the prime of its life, burning brightly and steadily. Imagine the sun as a colossal cosmic furnace, fueled by a nuclear reaction that's been ongoing for billions of years. This fiery sphere, with a diameter of about 1.4 million kilometers, is a powerhouse of energy, casting its light and warmth across the vast expanse of our solar system. In its heart, the sun's core, where the temperature soars to an unimaginable 15 million degrees Celsius, a nuclear fusion process is at work. Here, hydrogen atoms are constantly being fused together to form helium, releasing vast amounts of energy in the process. This energy radiates out from the sun's core, traveling through the outer layers until it finally escapes into space as sunlight. This sunlight, which takes approximately 8 minutes to reach us, is what makes life on Earth possible. It provides the heat that warms our planet, drives our weather, and sustains all life. Without the sun's energy, there would be no photosynthesis, and without photosynthesis, there would be no plants, no oxygen, and ultimately, no life. But the sun's influence extends beyond just light and heat. It also emits a stream of charged particles known as the solar wind, which interacts with Earth's magnetic field to create phenomena like the aurora borealis, or northern lights. And let's not forget about the sun's gravitational pull, which keeps Earth and the other planets in their orbits, ensuring the stability and order of our solar system. The sun, in its prime, is a cosmic marvel, a testament to the power and complexity of the universe. It's a star that's found the perfect balance between the forces of gravity pulling inwards and the pressure of its nuclear reactions pushing outwards. Our sun has been in this stable stage for about 4.5 billion years, and it's not planning to retire anytime soon. It will continue to burn, to shine, and to sustain life on Earth for another 5 billion years or so. This is the sun in its prime, our lifeline in the cosmos. But what does the future hold for our sun? Will it continue to shine brightly for eternity? This question has perplexed astronomers for centuries. As we journey through time, we'll find that our sun, like all stars, has a life cycle. In about 5 billion years, as the sun exhausts its hydrogen fuel, it will enter a phase known as the red giant branch. The core of the sun will shrink while its outer layers expand. Our once friendly neighborhood star will swell to a size so monstrous it could swallow planets like Mercury and Venus and possibly even Earth. But don't pack your bags for Mars just yet. This red giant phase is still billions of years away, and even then, it's only a temporary stage in the sun's life. As the sun continues to burn through its remaining fuel, it will undergo a series of pulsations. These cosmic heartbeats will eject the sun's outer layers into space, creating a beautiful cosmic spectacle known as a planetary nebula. What remains of the sun after this dramatic shedding of its outer layers is a dense, hot core. This is known as a white dwarf, the final stage in the life cycle of stars like our sun. White dwarfs are incredibly dense. Imagine squeezing the mass of the sun into a space no larger than Earth. They shine with a ghostly white light but don't generate any new heat. Eventually, over billions of years, they cool and fade into the darkness. So no, our sun won't shine brightly for eternity, but it will leave behind a stellar legacy. It will transform, shedding its outer layers and exposing its radiant core. It will illuminate the cosmos with its dying breaths, a testament to the life it once had. In about 5 billion years, our sun will bid adieu, leaving behind a stellar legacy. A legacy that speaks of a star that once nurtured life on a small blue planet in the vast expanse of the universe. Throughout history, the sun has been the subject of numerous myths and legends. From the ancient Egyptians to the Romans, from the indigenous tribes of America to the far reaches of Asia, the sun has played a central role in countless stories and traditions. It has been worshipped, feared, and revered in equal measures, often personified as a god or a powerful deity. Take for instance the ancient Egyptians who revered the sun as Ra, the god of the sun. He was considered the ruler of all parts of the created world, the sky, the earth, and the underworld. He was often depicted as a falcon-headed man wearing a solar disk on his head, symbolizing his power and dominion over the world. In Greek mythology, the sun is personified as Helios, who rode across the sky in a chariot pulled by golden horses. Each day, he would make his journey, bringing daylight to the world, only to return at night, plunging the world into darkness. Across the Pacific, in Japan, the sun goddess Amaterasu, from whom the Japanese imperial family claims descent, is a central figure in Shinto religion. She is the goddess of the sun, but also of the universe, embodying the concept of light and warmth and their importance to life. In indigenous American cultures, the sun is often associated with the concept of cycles, balance, and transformation. For example, in the Hopi tradition, the sun chief, Tawa, is revered as the creator of the earth and its caretaker. These are but a few examples of the myriad ways the sun has been interpreted and understood throughout history and across cultures. Despite the variation in myths and legends, there is a common thread that ties them all together: the recognition of the sun's vital role in sustaining life on Earth. Despite these fascinating tales, the sun is a star, burning brightly, fueling life on our planet. The sun, our closest star, has a profound impact on our lives. This massive ball of burning gas, some 93 million miles away, is more than just a celestial body that lights up our sky. It's the driving force behind our planet's climate, weather, and indeed all life on Earth. Let's delve into this a bit further. The sun's heat warms our planet, creating the conditions necessary for life to exist. It drives the water cycle, causing evaporation, cloud formation, and ultimately rainfall. This cycle not only provides us with fresh water, which is essential for survival, but also shapes our weather patterns. The sun's energy fuels photosynthesis, the process through which plants convert sunlight into food. This process is the basis of life on Earth. It's a beautiful symbiosis where we breathe out carbon dioxide that plants need for photosynthesis, and they, in return, release oxygen that we need to breathe. But the sun's influence goes beyond that. It's also a massive powerhouse of energy. Solar energy is a renewable, clean, and abundant source of power. As we struggle with the impacts of climate change and the depletion of fossil fuels, harnessing the power of the sun is becoming increasingly important. However, it's not all sunshine and rainbows. The sun also emits solar radiation, which can be harmful. While our planet's magnetic field and atmosphere protect us from most of this radiation, some of it does reach the Earth's surface. Overexposure to solar radiation can lead to skin damage and other health issues. But don't worry, with the right precautions like wearing sunscreen or protective clothing, we can safely enjoy the sun's warmth and light. Indeed, the sun plays a crucial role in our existence, making life as we know it possible. So, the next time you bask in the warmth of a sunny day, take a moment to appreciate the immense power and influence of our closest star. So, what have we learned about our fiery friend, the sun? We've journeyed through cosmic marvels, from the birth of the sun to its eventual future. We've seen how the sun, our closest star, is much more than just a bright spot in the sky. It's a cosmic powerhouse, the heart of our solar system, and the source of life as we know it. We started at the very beginning, with the birth of the sun. Born from a vast molecular cloud around 4.5 billion years ago, our sun took shape, igniting its nuclear furnace to become the glowing orb we see today. It was a process of cosmic proportions, a testament to the grandeur of the universe. Then, we moved on to the sun's childhood. Like a child growing, the sun spent its early billions of years maturing and stabilizing. It was during this time that the sun's energy output became steady, creating the stable climate conditions necessary for life on Earth to evolve. Next, we looked at the sun in its prime. The sun is currently in its main sequence stage, burning hydrogen into helium in its core. This process releases immense amounts of energy which radiates outwards and provides the heat and light we enjoy on Earth. We also peered into the future, delving into the sun's eventual demise. Billions of years from now, the sun will exhaust its hydrogen fuel. It will expand into a red giant, swallowing Mercury and Venus, before shrinking into a white dwarf. We've also explored the myths and legends surrounding the sun, from ancient solar deities to modern science fiction. These stories remind us of the sun's enduring cultural significance. Finally, we've discussed how the sun impacts our lives. From powering our world through solar energy to influencing our climate, the sun plays a pivotal role in our existence. And there you have it, the life story of our sun, a testament to the grandeur of the cosmos.